Okay, good morning everyone. Happy Friday.
Good morning.
How's everyone doing?
Tired.
Okay, same actually. Feel groggier than normal trying to get up today. Is it just first week tired maybe? So, actually I know what it is. It's cold today, which makes getting out of bed harder, and it makes my allergies act up. Because when you go from hot to cold, there's pressure shift, and basically the air is always trying to kill me. But I hope you are all well, and I hope this first week has gone well for you guys. We're going to end today, end the week today, just looking at how to do your homework, basically. Study through the different types of problems that we've got. And then I hope you go on to have a wonderful weekend. Any questions, needs, comments, concerns, or haikus before we start today? Okay, you guys just ready to get to sleep again? I don't blame you. I would be there if I didn't have a whole day ahead of me. So, it would help if I turned the projector back on. Keep looking at this like it's a watch, even though that will never accomplish anything. There we go. So, the notes that I present in this lecture, I'm always going to put on the Brightspace page. This one is not up yet because I was putting the finishing touches on it last night and this morning. But all the notes will be live on the Brightspace page for you to be able to refer back to. Contains all the different steps on all the different types of questions and a couple of examples that we do together. To start with, we already talked about the order of operations last time. Did the first homework question together. You've all been interacting with this for as long as you've been doing math outside of kindergarten, probably. And just a couple brief refreshers of two differing degrees. This is very straightforward. We're going to do this together very quickly. And then this might resemble some things that you'll be seeing in upper level math classes. So this is practice for things to come. First, we have 18 divided by 3 minus 7 plus 2 times 5. So what steps here go first? Very good. So what should 18 divided by 3 be? Very good. Minus 7 plus, and 5 times 2 is 10. And then, because this is all addition subtraction, it can all happen in one fell swoop. 6 minus 7 is negative 1, yes. Negative 1 plus 10 is 9. Now, this more closely resembles something that you might see in a physics class formula. Most of them are not this vertical, but you'll be plugging in a lot of numbers and the same things. So, for this particular question, we are told what x and y equal. So step 1 is to start plugging in every single value that you know. So, we've got 2 times x, that's going to be 2 times 1, minus 4 times y, which is 5 over 1 times 5 squared. Got to make sure that that squared is only operating on the 5. So in your order of operations, this exponent is only working on this number. Divided by 3 times 1 minus 6 times 5 over 1 to the 3rd power. Again, that third is only on the 1 times 5. So, in a lot of your physics problems, you won't have all of the variables known, and you'll have to find one of them. But in this particular case, we know everything here, so we can solve for just one number. First step is always the parentheses, and we really have two sets of parentheses that contain most of the problems. So what that means is we cannot begin by just dividing this into this, because there's a bunch of things inside of each parentheses we have to deal with first. Once you start with the parentheses, you look within that parentheses and start working from there. So next step is exponent. So within each exponent, we'll look at, within each parentheses, we'll look at those. Okay. I might take a few steps. I might go ahead and start combining a few things, namely all of the 2 times 1s or 3 times 1s. Are we okay with that, Lee? Okay. So I'm going to skip to that being 2. These are being multiplied together. Okay, if we skip to that being 20. Very good. Next we have 1 times 5 to the 2nd power. So that power is only operating on the 5. That's going to be 1 times 25. Next, 3 times 1 is 3, minus 6 times 5 is 30. 1 to the 3rd is 1 times 5. How are we doing so far? Okay, very good. So within each parentheses, we've done the exponents. If you think multiplication and division should come next, you can multiply 1 and 25 together and 1 and 5 together. And then we would want to divide this by this and this by this. That said, yeah. Okay, let me go ahead and write that step out, just so there's less to extrapolate. So, what do you guys think the next best move should be? Yes, good. Okay. Sorry, I lost my train of thought there. That just means I need some water. Yes, working the numerator next would be the next best move. Because if we were to go ahead and try to divide this into 25 before doing the numerator, we would get 2 over 25 minus 20 over 25, which is just going to add back together into 2 minus 20 over 25. So it might not feel like doing the subtraction first is the order of operations, but it technically, or it would wind up being the same thing. So 2 minus 20 is going to give us negative 18. 3 minus 30 is going to give us negative 27. So what do you think our next move should be? Okay, very good. Getting a few steps ahead of you there. These are, 18 will not divide evenly by 25, and 27 will not divide evenly by 5. And then it'll be hard to eventually divide that fraction by this fraction. So I'm going to employ a trick, which is going to be part of the homework and part of the notes ahead of us. Very good job. Where we, instead of dividing by a fraction, we're going to multiply by the reciprocal. Because dividing by anything is the same as multiplying by its reciprocal. So we can rework this to look like 18 over 25 times 5 over negative 27. Okay. Now, since what you can do legally is multiply the numerators and multiply the denominators together, which means we can further compress this into negative 18 times 5 over 25 times negative 27. We can, because we're dividing a negative by a negative, those can go away conveniently. And I think the next best thing is to cancel out this 5 and just put that 5. Is that too big a leap? Are you guys okay? Is anyone not okay with any of this so far? I realize that's the way I need to be framing these questions. Okay. And whoops. I realize my work is all over the place here. I'm sorry, my board space is not very conducive for this. I am content leaving the answer like that for the time being. Yes.
Towards the last step where it's like 18 over 5 times 27.
Yes.
Can you do that again?
Sure. So I did kind of mentally skip a step there. I apologize. I was looking at the 5 over the 25 portion because we could split this 25 into 5 times 5, which would cancel out the 5 up top and the 5 on the bottom, which would compress us to, I've been doing this stuff for so long, I have a problem with actually writing all the steps down, which I realize is very against the point of this class. So if I skip steps, please remind me to rewrite them for you guys, because that is the point of the course, is making sure you know all the steps. So I will be attempting, that said, if there is something that I skip and you need to see it, please call me on it right then and there, because I might not give it a second thought, but I need to be giving it a second thought. Please do call me on it. 18 times 5. My 5s look like S's, I apologize. So 5 over 25 is basically the same as just 1 over 5. And so that would leave us with 18 over 5 times 27, which would get us to 18 over, what did I say, 135? 135.
What about the negatives?
Sorry?
The negatives?
Good question. So when you combine fractions, you can multiply the numerator by the numerator and the denominator by the denominator, which actually should have given us negative 18 times 5 over 25 times negative 27. Since these are being multiplied together, that's going to create one negative number. And since these are being multiplied together, that's going to create one negative number. So you've got a negative over negative, and that will cancel. That always happens to me. I need a better chair. It's not very comfortable either. So, this probably has more steps in it than any of your homework problems. This is just a wake-up brain. And it actually got into the next couple of points I wanted to make. Right? So, you're all familiar with the order of operations. That's entirely reviewed to you guys. But I made sure to write it down so that you have them in the notes. Is how to do the fraction questions, because there is a section on the homework assignment that is fractions. And we basically touched on all of these in this series of events that we just performed. So, order of operations by itself refers to, will help you with finding the numerical answer on 1 through 3 and 25 through 31. But 25 through 31 are also fraction questions, so you need to employ specific tactics to use the order of operations to your advantage there. Again, we touched on most of these while we were doing the questions together. If you multiply two fractions, you multiply the top of the top and the bottom of the bottom. If you're multiplying a whole number by a fraction, recall that that whole number can be rewritten as blank over 1. So top to top, bottom to bottom. And dividing by fractions is, again, you can rephrase this as multiplying by the inverse, which would then be 9 over 1 times 2 over 3, which will simplify this to 6. Yeah, we just did this a moment ago, so this is in the notes that you, if you want to access this while you're doing your homework, just as a refresher, they will be on the Brightspace page. In the spirit of getting the homework started with you guys here in the room, if you have your sheet open, I would like to draw our attention to question 25. Where we have 3 over 4 plus 3 over 5 plus 1 over 3. Now this is adding fractions. Oops. Oh, I see. Sorry, my notes are. I accidentally included 2 slides with only 1 difference on them. Sorry about that. This is the full slide, which contains the tip for adding fractions together. So, we want to get one numerical answer, but can we just add these directly? No. You can multiply the tops of fractions together and multiply the bottoms together, but you cannot add fractions unless the denominator is the same across both. So what common factor do you think we should make the denominator by in this case? Okay, so if we try to make the denominator 20 for all of these, why won't it work?
The 3.
Very good. 3 does not go evenly into 20 or vice versa. Yes?
45.
45. Okay, that should work. 45 is divisible by 4, that would be 9, correct? I'm not as good at mental math as I should be.
That's
No, I'll take that back. No, because it would be 5 times 9, it would be 45.
Okay. So 49 is out, but it's good though, we're working through the numbers. The easiest thing to do, the quickest way to get to a number, even if it's not the smallest, is just multiply all of these numbers together. So what's 3 times 5 times 4? 60. So to make them all 60, it might not be the smallest thing that could work, but it's at least a thing that can work. So what do you multiply by 4 to get 60? 15, very good. So this is going to be 15 times 3 over 60. Does this follow? Does anyone not understand how we got to this number? Does anyone have an issue with that? Okay. I know this is all review, but it's review that is part of the class. What times 5 is 60?
12.
Very good. 12 times 3 over 60. And then what times 3 is 60?
20.
I'm just going to go ahead and make that 20 over 60 instead of doing the 1. Okay. Order of operations tells us we need to deal with those multipliers before we can add things together. So what is 3 times 15?
45.
Very good. And 3 times 12?
24.
And now that they're all the same, we can add 24 and 45 and 20 together to create, I think that's 89.
Is 12 times 3, 24?
Oh, wow. I have this problem, I don't know if it's actually a diagnosable thing, where there's a number in my head, but neither my mouth will then say the wrong number and my hand will write the wrong number, even though I swear I thought 36, but that's not what I wrote down very clearly. Thank you for noticing that. I'm a human, I make mistakes. I apologize. Sorry about that, that was an accident. It mostly happens when I'm telling time. Like it'll say 5:20 and it'll say 7:20 for no clear reason. So I will do my best to be diligent. If something slips through though, please do call me on it. I am not afraid of being proven wrong. So these added together should actually be, sorry, can I say again?
101.
101? Okay, thank you. And then 101 over 60 should be 1 point something, I think.
1.68.
Thank you very much. And that is homework question number 25. Later on, if we have time in the rest of the class, we're going to continue working together on the homework directly. Before we move on from fractions to making sure we understand the other parts of the assignment, I want to draw your attention to number 27, because it's the only fraction question that has letters in it. And the letters are not meant to alarm anyone. It just means that you won't be able to find a numerical answer. Your answer here is supposed to still have letters in it. If we were to try to add these together, this is supposed to be a B, not a 6. Is that a little more obvious? To add these together, there's not going to be a number that we can make these, but there is a combined letter that we can make the denominators. So, what do you think our combined denominator should look like? AB. Yeah, AB. Which means that we need to multiply the top and the bottom here by B, excuse me, and the top and the bottom here by A. And so, your final answer is more than okay to be left like this. That is as far as you can work it. And I will try to keep my B's from looking like 6s. Any questions or needs thus far? Yes.
I think one of the questions has like 5, like a mixed number. How do we do with this to make it like just a fraction?
Sorry, when you say mixed number,
It was like 5, and 3 over 2.
Number 6. Yeah, it's number 6 on the sheet.
Yeah.
oh.
How do we do with those numbers? I forgot.
So that would be 5 times 3 over 2. And that is a good question, because next we're going to start talking about these types of algebraical ones, and we can work that together. Now, in physics, most of what we're doing is technically algebra, in that there's something within the question you don't know that is left as a variable, and you have to, rearrange and do the order of operations to get to just that answer by itself, just that variable by itself equals blank. So most of the assignment that is can't find my words. Most of the assignment is these types of algebra questions, where there is an x living somewhere in there that you want to solve for. For example, 5 times, open parentheses, 3 minus x squared, close parentheses, equals 10. In all of those formulas, your goal is to get to x equals blank, and it is your job to use algebra to dismantle one side to get there. And the notes in the assignment might refer to this as SADMEP, because in order to dismantle a side, you tend to do the order of operations in reverse to get there. Now, has anyone, I assume through high school you've all had an algebra or geometry class. Has anyone not? Okay. So this should also be a review, but this whole week is review so that we can get to new stuff later. Got to build up from the ground. So pretty much all of your physics formulas and questions are going to look something like this. So if we're going to start getting to 10, what's our first step? What's the first thing we have to undo? Okay. Oh, okay. You're right. We could distribute the 5 in. So what else?
Probably easier to divide by
I would recommend dividing by 5 first. If we look at this whole side, this x is buried within this exponent, these parentheses, and then this is acting upon the parentheses. So to get to that x, we have to peel back all of these layers, which means we need to be moving them over here. So I'm always in favor of a step that gets something to the other side where it's just not a problem anymore. Legally, we could use the distributive property to pull the 5 in and deal with it later, but I'm in favor of getting it over to the other side as quickly as possible. So to move something from one side to the other, you have to basically perform its inverse operator. To detach this 5 from this set of parentheses, we need to divide this side by 5, which will cancel it out. And whatever you do to one side, you have to do to the other. I'm going to try to list these steps very specifically one at a time, because I know myself and I tend to skip them, so I'm going to be very intentional here. These 5s will cancel out, which should just leave us 3 minus x squared equals 2. What is the next thing we want to get rid of?
The 3.
Very good. This 3 is being added, subtracted to this side. So we're going to want to, this is a positive 3. So the 3 is being added and this is being subtracted from it. So to get rid of that 3, we're going to want to subtract a 3 from that side, which means we subtract a 3 from this side, which should get us x squared, negative x squared is equal to negative 1. Any issues so far? Okay. Now, 2 things left. We have a negative and a square. Which should we get rid of first? Very good. Because again, we kind of want to go through the order of operations in reverse, which means multiplication this away should come before this exponent. So we're going to basically end up just dividing both sides by a negative 1 to cancel those negatives out. That's how I recommend writing it down. And then we're ultimately just going to end up with x squared equals 1. Last step, how do you get rid of a square? Square root. Very good. So square root of x squared equals square root of 1. What's the square root of 1?
1.
Technically, yes, it would be plus or minus 1. Very good. That is actually a very good step that I usually forget to do myself. So it should be plus or minus 1. I will accept just a positive answer usually on an assignment, but to be as correct as possible, plus or minus would be a very wise thing to do. So, if we turn our attention to the assignment itself, a very good question was raised about number 6. And I say we look at that one together because it's one of the more complicated problems in that section. So the whole thing of 6 is 2 to the 3rd power minus 9 minus 8 over 3 plus x minus 5 times 3 over 2 equals 18. Which is a lot of things going on at once, but the one thing we care most about is that x. We need to get that in the numerator and by itself. So what are your thoughts on the first term we should try to get rid of?
5 and 3/2.
Very good. Again, if we're trying to employ the order of operations in reverse, we want to deal with things being added or subtracted to our, like this term right now is our target because it has the x in it. So we need to deal with things being added or subtracted to it first. So we can add 5 times 3/2 to the other side. To get rid of it, my 5 look like s's, I apologize. That will leave us with 2/3 minus 9 minus 8 over 3 plus x equals 18 plus 5 times 2 over 3. Now, the question that was originally asked is how to deal with this. I think that did come up in your original question. So this 5 is being multiplied by the 3 over 2. And the way that I would recommend rewriting it, if it'll help make your multiplication simpler, any whole integer can be rewritten as that integer over 1. So 5 over 1 times 3, times 2 over 3. Yes.
If you only subtracted it, would you flip around the fraction? Because it was 3 over 2, and now it's 2 over 3.
Oh, no, that's entirely because I just wrote it wrong in a mad fit of penmanship. Excuse me.
Take it out of the mixed number and just turn it into a fraction, like 5 times 2 plus 3, or 2 times 5 plus 3. So, it becomes 13 over 2.
I'm sorry, can you say that one more time?
You take it out of the mixed number into a fraction and turn it to 13 over 2. Yeah, 2 times 5 plus 3 to get rid of the next number. Or I just did it the
No.
long way. I guess I just did it probably the long way.
Well, it sounded like what you were suggesting looked something like this. Is that what you were thinking about? So that would work if it was 5 over 1 plus 3 over 2. In order to add the fractions, the denominator needs to be the same. But when you are multiplying, if you are multiplying anything by a fraction, the denominator and the denominators don't need to match. If you are multiplying 5 over 1 times 3 over 2, you just want to multiply the two top numbers together and multiply the two bottom numbers together, which would look like 5 times 3 over 1 times 2. And that should eventually simplify to 15 over 2, which means our entire complex number can be made into 7.5. any issues with arriving at 7.5? Okay. Would anyone disagree with me writing 7.5 right here? Just to go ahead and compress that. Okay. Okay. Now, on our left side, our target term now has nothing being added or subtracted to it. It has nothing being multiplied or divided into it. This is just our one term that contains the x. So now we want to focus on dismantling this term to eventually get the x by itself. Now, frustratingly, the x is on the bottom. So what do you think our next move should be to try to get it on the top side? Very good. We can multiply both sides of our equation by the entirety of this term, by 3 plus x. And we want to do that to both sides. And that should give us 2 to the third minus 9 minus 8 equals, open parentheses, 18 plus 7.5, close parentheses, times 3 plus x, close parentheses. Note that we multiply this entire side by all of 3 plus x. It's not just 7.5 times the term, it's the term times the entire thing. Because we had to we multiplied this whole side by 1 plus x, which means we have to multiply this whole side by 3 plus x. So that kind of creates some parentheses to make sure all the terms remain as they were originally before we did this step. Again, our goal is to get the x by itself, so what do you think our next best step is?
Solve the left side.
We can go ahead and solve the left side. That'll help compress things a little bit, which will make writing a little less tricky. So if we want to simplify this to just a number for the sake of simplicity, what's the first thing we should do over here to try to get this to one number? Very good. So 2 to the third power is 8. Very good. So that's going to leave us with 8 minus 9 minus 8. So this whole piece will simplify to negative 9. Does anyone object to how I wrote that? It is okay if you do. I can write out the steps more specifically, but all of this together adds up to negative 9. Along the same token, we can go ahead and compress this as well. So what's 18 plus 7.5?
25.
Yes, yes it is. And the last term is this, which cannot be compressed because we don't know what x is. Now again, our goal, to get to our eventual end goal, what do you think our next step should be? Divide by what?
25.
Okay, very good, because that's going to get a term over to the other side and out of our hair instead of putting it in and distributing it in and then having to deal with it again. Also, I don't know if I mentioned it or not, my ears aren't super great in general. That's before the air conditioner and the slight echo in the room, and the fact that everyone's voice is going to be somewhat muffled to normal. So if I ask you to repeat yourselves, I do apologize. It's just because I mechanically am having an issue hearing you. So, want to divide 25.5 into both sides to cancel it on the right. It's going to give us negative 9 over 25.5 equals 3 plus x. And so what is presently our last step?
Subtract 3.
Okay. We can subtract 3 from both sides. That will look like this. Because this is an entire fraction. You can't just subtract the 3 into it yet. So right, these are still two separate terms at the moment. And we are at least at our end goal of x equals blank. We have made that goal. Congratulations. Now, we would ideally like a number for x. So, if I was to just take a moment, just for context, not changing anything too much, just a reminder that 3 can be rewritten as 3 over 1. If we were to try to combine these to get to a number for x, our next step would be just trying to combine these fractions, making sure they have a common denominator. And I think that 25.5 is a common denominator enough for our purposes. So negative 9 over 25.5 minus 3 times 25.5 over 25.5 equals x. From here, if you feel comfortable with it, your calculator could tell you just what the final number should be. But just to write all the steps out so that you have them. Negative 9 minus 3 times 25.5 over 25.5, which still looks like a bit of a mess, but at least we have our end goal. X is equal to something. And my handwriting is still awful. I apologize. I feel comfortable leaving it there for right now because there's one more slide that I absolutely have to show you before the weekend starts. Yes?
Why don't you work out the numerator?
We can. We definitely can.
Is there like some reason or?
There's no reason not to.
Okay.
It's just, that'll take another couple of minutes that I need to spend showing you something else. So have this on your paper. This is perfectly correct. I just want to show you something else more than I want to get to this final number right now. And that something else is the logarithm part of your homework. Because even for me, logs are one of the trickier things, just because I do physics, and I don't even use them that much, but it's important to know them for when they do come up. And I do recommend you pull up this slideshow on when I upload it to the Brightspace page. You have it so that you have exactly this visual on hand. Logarithms take a lot of different forms. Basically, the entire logarithm section of the homework has various things that will look like each of these different terms right here. And a logarithm is just a unique type of operator, like a square or a square root, which means all of these have inverses that you can use to try to break it down and move it to the other side. I find them harder to remember, which is why I recommend you pull these notes up and have this visual up while you're doing the homework. And since we're nearing the end of class, we will continue with this on Wednesday. Your first assignment's not going to be due yet. On Wednesday, we will continue working these examples together, specifically a couple of these things. I at least want to make sure your eyes have witnessed this first before you start working on them on your own. again, we'll come back, we will keep working on them Wednesday, but I advise you to begin working on your own in groups over the weekend so that any hang-ups and issues you come across, you can come prepared for questions and feedback. And then again, these operators have inverses that you can use to move the logarithm around. For example, if I was to start comparing a couple of the homework questions to the shape of a few of these, I have one eraser for this entire giant board. I need more. For example, I'm going to compare this one right here, n equals e to the x, to the homework question of 21, 55 equals e to the x. As with most things in this class, our goal is to arrive at x equals blank, but how do you get the x down if it is itself the exponent in something? The answer is using logarithms. If the logarithm takes this form, where n is a constant equal to something raised to the x power, the operator that you want to perform on both sides is this natural log right here. If you have something raised to an x and you want that x by itself, what you want to do is perform natural log, which is ln, I guess log natural, if that helps you remember, equals, that operator would act upon the 55, and whatever you do to one side, you have to do to the other as well. So we're doing the natural log operator to both sides, and this is kind of like taking the square root of a square. The natural log and the e cancel out, and it'll just leave you with the x by itself. It's a weird form of canceling, because it puts the x down here and then cancels it, but it does cancel. And it'll leave you with natural log of 55 equals x. And natural log it's an operator, which means your calculator should have a button for it. It's like sine, cosine, tangent, all of those. On my machine, which again is ancient, I do see your hands.
Just in hand, you were kind of explaining what I was going to ask, like, plug it into a calculator.
Okay, I'm very glad then. Yes, natural log and the logs that themselves aren't natural have a button on this machine that you can just use. So to do this on your machine, you can literally press ln, natural log, type in 55, close the bracket, and press enter. And I recommend doing that because it's kind of like sine, cosine, tangent. There is a formula for it, but it's long and annoying, and we programmed the computers to do it for us. Yes?
For problems like these, do we need to write out the work?
It would help me when grading them. As much steps as you can include, make it easier for me to see what you did and add partial credit. But like if I was doing this on my own as a student, I would probably jump straight from here to here. Because this step is just canceling the ln and the e. And then you can solve what ln 55 is. What time are we at? Okay. So typically more work, more better, but I'll leave it to your discretion because there are some things that just get tedious to write. I totally understand that. And this step doesn't tell you much more other than these will cancel and then you've done this. So You are allowed to use your common sense in terms of what lines of the steps will be most beneficial, and you can trim out things for the sake of not developing arthritis. That is to your discretion. We're at the end of the period now, and I definitely don't want to keep you into the weekend, which is why we're going to be continuing this and working through these problems together on Wednesday. That's why we're taking 2 weeks for this homework assignment. We had to spend all of Wednesday warming up. So, and this will be due Wednesday after next, which I think is February 8th, I think. Something like that. And do have these notes up to refer to this sheet, specifically this list here, to figure out how to cancel the natural laws when you get to those in your homework. You'll be working together, and we will continue working on these together, because this is also part of the classroom assignment together on Wednesday. Send me any questions you have as you're working. Yes?
That law, we're not reading it like that, we actually want that number, don't we?
Well, me grading it, I'd be okay if you left it like that, because the number is, I just solved it, 4.007333. So me to you, I'm okay if this was your answer, frankly, because oftentimes a textbook will leave it like this, or someone writing it out will leave it like this. So you're okay getting to this point. This is just the point where a machine would take over anyway. Any other questions? Okay. Again, we'll get back, we will do these together in class Wednesday, but I encourage you to be looking at them, be working on them on your own, so you become prepared for any issues that you find. And I do hope you have a wonderful weekend, a nice restful one. The weather stays nice, enjoy it. I'm rambling at this point, you're welcome to go. You never have to stick around for me to talk. It's like filling the dead air. Have a great day, guys.